Alright, let's try another inverse problem. Again, switch the x and y's first. Now how do I get rid of that square root? The root is on fire. We're going to square both sides. That's right. Very good. That squared gets rid of the square root. That was the whole purpose there of squaring both sides, not just because we enjoy squaring stuff. I mean, I do, but I want to do it for a purpose. And now I can add that 1 to the other side, and I get x squared plus 1 equals y. So I have y to the negative 1. Remember, that signifies the inverse of the original function. We have x squared plus 1, so there we go. Awesome. You may also see the y written as an f to the negative 1 of x instead of just f of x. Again, that negative 1 being like that, it's the inverse. Alright, so let's try and find an inverse of a function. Now remember, when we're finding an inverse, we're basically just switching our x's and y's to start. So I'd have x equals the square root of 2y plus 1. And then I'm going to resolve this whole thing for y. You're going to just rearrange the equation in a way. So in order to get rid of a square root, I need to square both sides. So I'm going to have x squared equals 2y plus 1. The squared and the square root cancel. That's why we squared both sides. That was our whole purpose. Now I want to isolate that y, so I'm going to have to subtract the 1 first to get x squared minus 1 equals 2y. And then how do I get rid of that 2 in front of the y? That's right. I'm going to divide by 2. So what I end up with is y equals x squared minus 1 over 2. And what you'll usually see is a little negative 1 in the exponent of that y, signifying that it is an inverse of the original equation. Or you can see it written in function notation with f to the negative 1 of x equals x squared minus 1 over 2. But either way, you'd usually see that negative 1 saying, hey, this is the inverse.